This is a description of programming exercise number 38, the last programming exercise of the semester. And it's a pretty involved program that should take you some time to write. Although I think you can put the pieces and parts together in a pretty straightforward manner from what we've covered, or what I've covered in the last few presentations. Okay, this program concerns object-oriented programming, class declarations, constructor functions, accessor functions. Write a C++ program that creates a class of objects called complex. These objects, use these objects to represent complex numbers. The two data members of the class shall be the real part and the imaginary part of the complex number. If you look at the example code that was used with the previous presentations, it shows the format for declaring a class. You have the class name, or the keyword class, and then the class name, and you would use the word complex instead of rectangle. And first you have the private data members. The example has type double numbers for the width and the height of the rectangle. You will have a real part and an imaginary part of a complex number. The member functions of the class shall include a default constructor and a constructor that accepts the real part and the imaginary part as parameters. That was demonstrated with this example for the rectangle, a default constructor and also a constructor that takes parameters, and the definition for the constructor is on this same page. A function that sets the value of the real part and sets the value of the imaginary part. You have example functions for those as well. This description for the class rectangle has functions to set the data members and also to retrieve the data members. You would need to do a bit of a calculation to find the magnitude and the angle of the complex number, but you have information about that in the document that is entitled Information About Complex Numbers in this document entitled, I think it's Review of Complex Numbers. The description of what a complex number is with its real and imaginary part, and then an equation to determine the real part, the magnitude of the complex number, which is essentially the Pythagorean theorem, and also the angle of the complex number. In addition to this, you also had a program you did earlier in the semester. I cannot remember the exercise number, but you wrote functions to perform these calculations earlier in the semester as well. A function that displays the number in the form real plus j times the imaginary, and a function that displays the number in the form magnitude at angle degrees. So it would seem that you would want to allow for a function call to return the magnitude of the complex number. And if you call for a function that displays the number in the form of magnitude at angle degrees, one function will have to call another function. I'll leave it to you to work out the programming details. And the last part of this is overloading the numerical operators so that they will now work with complex numbers. Now, there may be a library of available in C++ for complex numbers, but I do not want you to use that library. Do not use that library. I want you to write the program and the functions to overload these functions, overload these operators, so that they will work with the class of complex numbers that you are programming. And again, you have the information on the numerical operations for complex numbers in this document that is reviewing complex numbers. How to do complex number addition and subtraction is carried out the same way, and complex number multiplication, and also complex number division. So you have the functions already worked out, or you have the mathematics already worked out. You just have to program them into your functions. And you've already done this before when you did the other programming exercise that dealt with complex numbers. This time it's just a matter of overloading these operators so that they do all the same operations. Okay. Then write a main function that will demonstrate all of the capabilities of this class definition. So I'll leave it to you to devise a main function that incorporates all of these function calls and demonstrates that they work. To document this, you need, as usual, a Word document with a written description of the program, a diagram to illustrate the structure of the program, the code listing, and screenshots that show the operation of the program, illustrating that all of the functions are operating correctly. I recommend that when you write your program, that you write one function at a time. You first declare the class with its data members, and then when you start writing the functions, write them one at a time. And after you write a function, write a few lines of code inside your main function to test the function, and build one function upon another until you've finished the entire program. Okay, so that is programming exercise number 38. Oh, that should say 38 right there. We'll edit it. 38. And that is the last programming exercise for the spring semester of 2020. Thank you very much.